Hello and welcome. In this video, we'll discuss about inverse trigonometric functions. So before we dive into the actual topic, let us brush up some basic concepts which is needed for these functions. That is invertible functions. That is invertible functions. So for any function, f of x, the inverse function, the inverse function, the inverse function, f inverse of x exists only if f of x is bijective. If it is bijective, then only inverse function exists. So, or I can say f of x is invertible only if f of x is in bijective. That is when I say bijective, it means it should be both 1 and onto. So let us take one example to to recap what we have discussed in the previous classes. What I'll do is I'll take a straight line which is like this. This is my y-axis. This is my x-axis. Let us take this equation as I'll take it as 2x plus 3. I'm not sure if it is 2x plus 3 or not. Let's assume it is 2x plus 3. Now, if I pass any horizontal line through this function, the horizontal line touches the function at only once. At every point, it only touches at once. So this function is clearly 1 1. This is clearly 1 1. And if you are checking this under real number, this function, this straight line covers entire real number in the y-axis. So the range it is covering in y-axis is complete real number. So it is onto. So it is both 1 1 and onto. Hence straight line of the form mx plus c is always invertible. Is always invertible. If I take one more example, let's say we have a quadratic function like this. Now if I push any horizontal line through this function, let's say if I put like this, you can clearly see that this line is touching the function at 2 points. Let's say this is minus a and this is plus a, so this is c. So here f of a is c and f of minus a is also c. So two input values are pointing to the same output. Hence it is not 1 1. It's not 1 1. So to finding inverse for this function is not possible because if I want to find f inverse of c, it has to give me only one value. So if let's say in this example, let's say this is my a and this is my c, then I can clearly say f inverse of c is equal to a. So that means for any input a, the output is only one, that is c. But here if I want to find f inverse of c, that is what values of input gives me the output c, then it is actually two values. So we cannot converge to only one value. So there will be a contradiction. So that is, it gives both a and minus a. The inputs, both the inputs a and minus a will give you the output c. So in these type of things, we cannot say this is 1 1. So these functions, like we have a quadratic functions like y is equal to x square. This is not invertible, not invertible, not invertible. So having these ideas, we can move on to discuss our primary thing, that is inverse trigonometric functions. Let us take one trigonometric functions one by one and see whether it is invertible or not, or if it is if there are any conditions we have to check to make it invertible. Let's take our simple trigonometric function y is equal to sin x. So here you can clearly see this is the function of, this is the graph of sin x. So if I pass any horizontal line through this function, so you can clearly see the horizontal line is touching the sine function at many points. So sine function as a whole, is not invertible, because it is not 1 1. It is not 1 1. So as a whole, sine is not, invertible. But if you take the branches of sine wave, branches of sine function, like this is my pi by 2. So from here, from this point to this point, if I take only this part of the sine wave, so let me write it outside. So if I take this part, it is this is minus pi by 2, 0, and pi by 2. So the graph looks like this, something like this. Now this is my 1, this is my minus 1. So now if I pass through any horizontal line through it, then you can clearly see this is 1 1, this is 1 1. And if we limit our vision from minus 1 to 1, from minus 1 to 1, so this function is covering every value from minus 1 to 1, so it is onto as well. So in this interval, that is from minus pi by 2 to pi by 2, and in the range minus 1 to 1, sine function is both 1 1 and onto, both 1 1 and onto. So in this interval, sine is invertible. Not only this interval, there are many such intervals where sine function is invertible. Like if I take next interval, that is from this is my 3 pi by 2. If I take this part of the sine wave, so I can write sine as this as like this. This is my pi by 2, this is pi, and this is minus pi by 2. Now if you pass any horizontal line like this, it touches only one point. So it is both 1 1 and onto. If our vision is from minus 1 to 1, so it covers all the values from minus 1 to 1. So for this interval, sine wave is both 1 1 and onto. So there are many branches like this where sine wave is invertible. And while considering, we'll take one main branch, that is from minus pi by 2 to pi by 2. This branch where sine is invertible, we usually take this, we'll consider this, and we call this as principal branch, principal value branch. So let me write where and all sine is invertible. That is, we can take this as well. We can take this. We can take this. So there are infinite branches like this where sine is invertible. So I'll write few. I can write from this is minus 3 pi by 2. This value is minus 3 by 2. So minus 3 pi by 2 to minus 3 pi by 2 to minus pi by 2 is one branch where it is 1 1 and onto, and minus pi by 2 to pi by 2 is another branch. Then we can have pi by 2 to 3 pi by 2, and so on. So I'm interested in this interval, and this is called principal branch. This is called principal branch. Now, now how to plot the inverse function for this? Let's take my principal branch. Let's take my principal branch. Like we have from minus pi by 2 to plus pi by 2. This is my 1, this is 0, and this is minus 1. This is sine x. Now let me write sine inverse of x. Or let me take another color. What I do is I take red to plot the axis, take white to plot sine inverse of x. So here, now the y axis value will become x axis value in the inverse function. It is minus 1 plus 1. This is 0 anyhow. And the y-axis values are minus pi by 2, pi by 2, and so on. So here sine 0 is 0. So here sine 0 is 0. So sine inverse of 0, is also 0. So this point. Now we have sine pi by 2. Sine pi by 2 is 1. So sine inverse of 1, is pi by 2. So if I take sine inverse to this equation, I'll get sine inverse of sine and sine inverse of 1. So sine inverse of 1 is pi by 2. So at 1, the output is pi by 2. It comes over here at 1. Next we have sine of minus pi by 2 is minus 1. So sine inverse of minus 1 is actually minus pi by 2. So at minus 1, it is minus pi by 2. So this looks like this, and it continues for other branches as well. You can clearly see here, this is what we get for the principal branch. For the other branches also it continues like this. So what I do here is finally I'll conclude with some summary. For sine function, to be invertible, if it is invertible, what is the domain and range? So the domain for sine wave, let me remove everything here. The domain, the principal branch domain is from minus pi by 2 to pi by 2. The domain is minus pi by 2 to minus pi by 2 to pi by 2, and the range is always minus 1 to 1. This value is minus, the y value is minus 1 to 1. For sine inverse of x, the domain and range will be reverse of sine of x. So the domain is the x-axis value. The domain is only this one. So it varies between only from minus 1 to 1. So domain is minus 1 to 1, and the range in this domain is the range is from this value to this value. So we are taking only one branch. So if you consider all the branch, then it is full real number. If I take only one branch, the range will be from minus pi by 2 to pi by 2. So the range is minus pi by 2 to pi by 2. Next, let's move on to the next trigonometric function, that is cos x. So here I'll take the principal branch from, I cannot take from minus pi by 2 to pi by 2, because if I take from minus pi by 2 to pi by 2, this is not 1 1. This is not 1 1. So what I do is I take this branch, So here clearly it is from here to here. It is clearly 1 1. So the for cos x, in order for cos x to have inverse function, the domain and range is the domain is 0 to pi, and the range is anyhow minus 1 to 1. For cos inverse of x, you can see here the domain and range for 0 to pi is, the domain is minus 1 to 1. You can see from, it varies, x value varies only between minus 1 to 1, and from 0 to pi, the range is from 0 to pi. This is what you have to remember. Next interesting function is trigonometric tan x. We can easily make out here, because in this part it is actually is actually invertible. So tan x, but it is not, the values are not defined at minus pi by 2 to pi by 2. The domain is, the domain for tan x, domain for tan x is minus pi by 2 to pi by 2, and you cannot include minus pi by 2 and plus pi by 2 because it's not defined at minus pi by 2 and plus pi by 2. It's infinity. And the range is, it completes all real number. It completes all real number. Takes all the values of real number. Let us take tan inverse of x. Tan inverse of x. Let me write the domain and the range of this. The domain is, you can see, you can clearly see here, domain is from minus infinity to plus infinity. So it is complete real number. It is complete real number. But the range it takes is, you can see here, from minus pi by 2 to plus pi by 2. So minus pi by 2 to, and minus pi by 2 to pi by 2, and it is not included because it does not it does not converge to minus pi by 2 or pi by 2. It seems to reach that value. It's not exactly it's not exactly equal to that value. Let us move on to the next function, cot x. You can see here, cot x, you can take this interval for it to be invertible. So cot x, what I do is, for cot x, the domain, the principal domain and the range. The domain is 0 to pi, 0 to pi. Both are not included because cot x is not defined at 0 and pi. The range is, it can complete it takes all the values from minus infinity to plus infinity. So it is complete real number. And let us write domain and range for cot inverse. The domain and range. The domain is complete real number. You can see here. And the range is the range is range is this much. The range is this, that is 0 to pi, 0 to pi, but it does not take the values 0 and pi. So this is my domain and range. Finally, we'll move on to secant x and cosecant x. Secant x, you can see here, you cannot take this. You cannot take complete this one because you draw a horizontal line, it touches at 2 points. So the interval you can take is from here to here, that is from 0 to pi. 0 to pi you can take. So for secant x, the principal domain is 0 0 to pi. 0 to pi, 0 is included, pi is also included, and pi by 2 is not included. You can see here because secant x is not defined for pi by 2, so I can remove pi by 2 from this domain. Similarly, now let us go to range. The range is it covers all the numbers from minus infinity to plus infinity, but it does not cover this value. So secant x will not take any value between minus 1 to 1. So the range of this secant x is, interestingly, the real number minus it does not include any values between minus 1 to 1. It includes minus 1 to 1, but it does not include, it includes minus 1 and plus 1, not any value between them. So this is actually minus 1, so any value between this. So this is my range. Next, let us find what is for secant inverse of x. Secant inverse of x, the domain you can clearly see, the domain is from, it takes it takes all the value from minus infinity to up to here, and it starts from 1, goes to plus infinity. So there is no value, it does not take minus 1 to 1. So the domain is real number, not minus 1 to 1. it takes -1 is included, but after that it does not take. And the range is from 0 to pi. This value is 0 to pi, but it does not take value pi by 2. So it is, and I can show you the range is complete real number. So from here it takes value from 0 to pi by 2, but it does not take the value pi by 2. Next, from pi by 2 it goes to pi. So the range is 0 to pi, except pi by 2. Finally, we move on to the final trigonometric function, cosecant x. So here you can clearly see I have to take the interval, to take the branch from here to here, from here to here. Let me write for cosecant x, let me write the domain and range. The domain is from minus pi by 2 to pi by 2, and both are not included because cosecant x is not cosecant, sorry. So this is included. This is included from minus pi by 2 to pi by 2. This is included, but it is not defined at 0, so I can remove 0. This is my domain. The range, this is interesting. The range is from minus infinity to minus 1, it takes all the value, and from minus 1 to plus 1 it does not take any value. From 1 to infinity it takes all the value. So it is complete real number, and we have to exclude minus 1 and 1. And for cosecant inverse of x, I can simply write domain as this, which is r minus 1 minus 1, and range as minus pi by 2 to pi by 2 except 0. Finally, we what we do is we write whatever we have. We write the summary what we have discussed so far. So trigonometric functions. So there is a way, there is an order to write this. So I truly recommend you follow this order to make everything simple. So first we have trigonometric ratio and the domain, and we have range or codomain. First we'll start with sin x, and we'll start with tan x, then cosecant x, then cos x, cot x, and secant x. So this is the way to remember, because these three follow some pattern. Sin x domain is minus pi by 2 to pi by 2, both are included. Tan x is minus pi by 2 to pi by 2, both are not included. Cosecant x is again minus pi by 2 to pi by 2, 0 is not included. The range is minus 1 to 1. This is complete real number, and this is complete real number except minus 1 and 1. So these three follow this format. For cos x it is 0 to pi. For cot x also it is 0 to pi, but both are not included. Open interval 0 to pi. For secant x it is 0 to pi, and pi by 2 is not included. The next, the range is minus 1 to 1. This is complete real number, and r minus 1 comma 1. So you can clearly see a pattern here. So this is easy to remember. So I highly recommend you follow this only. And let's move on to inverse trigonometric functions. So what I do is trigonometric ratio, or I should write inverse trigonometric function. its domain, its codomain or range. We follow the same thing here also. I'll use sine inverse of x first, tan inverse of x, and cosecant inverse of x. Then I use cos inverse of x, cot inverse of x, and finally secant inverse of x. So the domain is -1 to 1. This is complete real number except -1 to 1. This is important, minus pi by 2 to pi by 2. This is minus pi by 2 to pi by 2 in an open interval. This is minus pi by 2 to pi by 2 except at 0. For cos inverse of x, the domain is -1 to 1, real number except -1 to 1. Here it is 0 to pi with closed interval. Here it is 0 to pi with open interval. This is 0 to pi except pi by 2. And we can include one more column here. Solution or quadrant where there is solution, where solution exists. So we have minus pi by 2 to pi by 2. So minus pi by 2 to pi by 2, if I write like this. So this is my 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. So if I come in anti-clockwise direction, a clockwise direction, this will be my minus pi by 2, this is minus pi, this is minus 3 pi by 2, and so on. So minus pi by 2 to plus pi by 2. So minus pi by 2 is here, and if I want to go to minus pi by 2 to plus pi by 2, I have to go like this. So this is my first quadrant and fourth quadrant. So for all this solution lies in first and fourth quadrant. This we will discuss in detail while solving the problem. Next we have 0 to pi. 0 to pi is 0 is here, and 0 to pi is first and second quadrant. So first and second quadrant. So all this is necessary for us to proceed with the problems. Thank you for watching.